velocity. Okay, we look at the velocity. Okay, first one. Velocity is defined as the rate of change of displacement. Now, this is exactly from your physics book. Displacement of velocity is defined as the rate of change of displacement. Rate of change of displacement means the change in displacement with respect to time. How is the displacement change with respect to time? So in symbol form, it means that like this, your velocity is actually the displacement ds over dt. If you remember last time when we learned the rate of change, dt means the rate of change. So velocity is actually the rate of change of displacement. Then velocity is a vector quantity. It has both magnitude and direction. So velocity has both magnitude and direction. So that means the velocity has size, 10 meter per second, 20 meter per second. That is the size. Then the direction is where is the particle moving. The particle is moving towards the right or the particle is moving towards the left. If the particle is moving towards the right, then the velocity is positive. That means when v is greater than 0, it means that v is positive. Now later on, when you solve the question, they will tell you v is positive. Now when they tell you, the question tell you v is positive, it means that v is greater than 0. You must know how to change them to symbol form. And also, if they don't tell you v is positive, they say the particle is moving towards the right. If they tell you particle moving towards the right, it means that the v is greater than 0. You must know how to change them. Right. Now, we only know when v is positive, we only know the particle is moving to the left or to the right. Its position may be on the left or it may be on the right. We don't know. From the equation of the velocity, we only know the direction of motion. We don't know the position of the particle. So the equation of v will not show you where the particle is. Right. So we look at one example. Let's say v is 5 meter per second. Okay, if they tell you v is 5 meter per second, that means the v is moving towards the right hand side, and that's all we know, with a velocity of 5 meter per second, moving towards the right with 5. Where is the particle? Don't know. I just simply put here. It may not be here, the 3. This is the number line. I just put it at 3 there. It may not be at 3, right? Don't know, right? Then let's say if somebody tell you, oh, the velocity is 2 meter per second or 2 unit per second. We only know the size of the velocity. It is moving at 2 meter per second and the direction is towards the right. Where is the particle? We don't know. It can be at the negative position or it can be at the positive position. We don't know. Unless you find out the S, only then you will know where is the particle. Okay, next one. If the V is less than 0 or V is negative, it means that the particle is moving towards the left. The direction of motion is negative. The direction is towards the left. And sometimes they won't tell you negative or less than 0. They will tell you, oh, the particle is moving towards the left. When you hear this particle moving towards the left, it means that the V is less than 0. You must put in this condition, V less than 0. So let us look at one example. If they tell you, oh, V is negative 4 unit per second or negative 4 meter per second, what does that mean? It means that the size of the velocity, it is moving at 4 meter per second. and the direction is towards the left hand side. We don't know the position, so I just simply put it can be at the positive position. Don't know, right? Then if they tell you, oh, the v is negative 10 meter per second or negative 10 units per second, it means that the particle is moving towards the left, and the size of the velocity, the magnitude of the velocity is 10 meter per second or 10 units per second. Position, we don't know. It can be on the left hand side or it can be on the right hand side. Position, we don't know. Okay, now we look at one example here. Let's say the example s equals to 8t minus 2t squared. If I ask you to find the velocity, and you know the velocity is this one, ds dt. So you differentiate this s with respect to t, then you will get the velocity. Differentiate at 8t, you get 8. Differentiate 2t square, you have 4t. So this, from the equation of displacement, you can get the equation of the velocity, right? Now, I am now going to plot both the displacement and the velocity with respect to time. So the time I'm going to substitute in time 0, 1, 2, 3, 4, 5, 6. So with this time 0 to 6, I substitute inside the s. So when I substitute inside the s is 0, 6, 8, 6, 0, negative 10, negative 24. Now this line, these numbers here, shows the position of the particle. Then the next line, if I substitute the t into this v, okay, 8 minus 40. So I'm actually getting the velocity. So the velocity is 8, 4, 0, negative 4, negative 8, negative 12, and negative 16. Okay, so I'm going to explain to you one by one how to, what it means, right? What it means. It means like this. When the t is 0, the particle is at 0. The velocity at that instant, at that time only, because the velocity is changing all the time. So different time, you will have different velocity. So the velocity at a particular time is called the instantaneous velocity. This one. The velocity at any particular time is the instantaneous velocity. So here they say that instantaneous velocity is the velocity of the object at a particular instant of time. That means that let's say t equal to 10. During that time, the velocity is like that. Other time, the velocity is not like that. It is changing all the time. So when I look at this table, 0 at this time, t equals to 0, the position is at 0. The velocity during this particular time is 8 meter per second. Okay, so show. It means like this. Okay, when t equals to 0, the position is at here. The velocity at this time is 8 meter per second. Because here they say meter, so it's 8 meter per second. Second one, how to interpret the second one? 164. It means when your stopwatch click it is at the position 1. When your stopwatch is at the position 1, and during that time the instantaneous velocity is 4 meter per second, and it is at the position 6 meters from O. Okay, right. Next one, how to interpret 280. 280 means when the time is 2 seconds, the velocity is 0. It comes to stop, come to a rest. The velocity is 0. But during this time, where is the position of the particle? The particle is at 8 meters from the center O. Okay. Next one, this one, right? When the time is 3 seconds, the instantaneous velocity is -4. -4 means they are going towards the left. They are no longer going towards the right. They're going towards the left, and with a velocity of -4 meter per second. And the position now is 6 meter. So from 8 meter, they become 6 meter. That means it's moving backwards, and the direction of velocity is negative. Okay, next one. Next one is what? This one. T equals to 4, V equals to 8, the position is 0. So during this time, when the T is equals to 4, the velocity is -8, moving towards the left-hand side. And the position during this time is 0. That means it is at the center point O. Next one. T equals to 5, V equals to 12, S equals to -10. It means that at the 5 second, the velocity, the particle is at the position of -10 meters from O, and it is traveling with a velocity of -12. That means going towards that side, -12 meter per second. And lastly, when the time is 6, the position is -24 from O, and the velocity is -16. So it becomes faster and faster. Now, if you want to plot the graph of S against T, so this is the graph of S against T. So, okay. So the on the vertical axis, it is the displacement S. On the horizontal distance, they will show the time t in second. So the first line 0, 6, 8, 6, 0, -10, -24. So 0, 6, 8, -10, -24. So they show the position. And how to show the velocity? The velocity is shown by the gradient at that particular point. Can you see the green lines here? This green line, this green line here, this green line here. So the graph, the parabola, will show you the position of the particle. The gradient at those points, this green line, the gradient will show you the velocity at that particular time or at that particular position. Okay. Any questions so far?